Based on my conversations with students and courses like this over the last 10 years, this is probably a good time to talk a little bit about process. Right now, there's probably a lot going on in your design, in your team. You're brainstorming, sketching, making low fidelity prototypes, modeling things using back of the envelope analysis, CADing, FEA, coding motors, experimenting with functional prototypes, maybe a little bit of the system, maybe the whole thing, writing, making figures, and of course, explaining things to each other and debating with each other. So there's a lot going on, and that's actually good. And it makes it a good time to think about a few tips for how to make the best use of each part of this process. A very common error is to fall in love with one of the first designs that you sketch up, and then to not listen when the analysis or experiments are telling you that there's a problem. So don't forget to take a step back once in a while and think about substantive changes you could make to your design to resolve big problems. You'll also be doing analyses, a lot of analysis right now. And remember that your purpose in doing this is to understand your design better and the design domain better, and to improve your design over time. We definitely don't want you to do analyses just to fill in a part of your report, right? If you're ever in doubt as to what kind of analysis to do, choose the analysis that you think will actually benefit your design the most. At this point, you have many analytical tools available to you, so many that you can actually forget about some of the things that you can do. So this is a good time to breathe and remember your training.
Breathe. Just breathe. Reach out with your feelings. What do you see?
The island. Life. Death and decay that feeds new life. Warmth. Cold. Peace. Violence.
And between it all,
Balance. And energy. A force.
At this point, you know the ways of the free body diagram. You know to be clever about how you define the body and the moment balance point so that you can most effectively get at the answer to the question that you have. You know how to perform stress and buckling analyses and invert these to identify the value of a key parameter. And you know how to perform finite element analysis, how to set it up appropriately with constraints that best match the real system with varying degrees of accuracy and complexity as you move through the process, starting with just sketches and ending with perhaps assembly analyses that capture things quite well. You know a process for mass efficient design of components. You know how to look out for force and error amplifiers in assemblies, how to identify the key properties of catalog parts and find out what they should be using back of the envelope analysis. You know how to analyze gears for strength and efficiency, and how to analyze for energy loss due to sliding friction and minimize it. And you know that everything on this slide is really just a special case of the stuff from the previous slide. And you know the model of an electric motor, how to select a motor operating point that's appropriate for your task, and how to use gearing to achieve it. So you have this great set of analyses available to you. Mind what you have learned. Save you, it can. As you start to experiment with your prototypes, make sure you use them to the fullest extent possible. Experimental tests are very expensive in time and materials. So you want to approach this with thoughtfulness. Figure out first, what is it that you want to learn? What conditions will you apply? Like, what will you change as you repeatedly take measurements? And how will you interpret the results that you get? And a really good check, whether you've got a good experimental design, is to be able to write down a sentence that if the outcome were, and then fill in an actual possible outcome, I would know. And this thing that you would know, that should be the goal of your experiment. And be imaginative about your goals. You can use experiments to figure all sorts of things out about your design. Don't put the writing off until the end. It is a vital part of the process. And in real life, communication on the evolving design is always happening. Remember that one of the big benefits of writing about your design early is that explaining it will improve your understanding of it and the domain. And that will lead to ideas about how to improve the design itself. As you work with your teammates, make sure to listen to them. They have a lot to teach you. And make sure that your ideas are heard as well, because you have a lot to teach them. And finally, expect to iterate. You will have failures in this design project. It's just going to happen. It always happens. Things will break, things will get stuck, things will not move the way that you expect them to. And that's okay. Failure is a natural part of the iterative process of design. And you learn a ton from each mismatch between your expectations, read your model, and reality. And with each one, you can go back and improve your analysis, your understanding, your intuition of the system, and that will lead to a better design. So remember that the greatest teacher failure is.